The chain rule is arguably the most important rules about derivatives. It's certainly the most frequently misapplied. The chain rule applies anytime we're taking the derivative of a composition of functions. What the chain rule says is that if our function h of x is of the form f of g of x, then h prime of x is equal to f prime evaluated at g of x times g prime of x. Here is one way to think about it. We have basic derivative rules for our basic elementary functions. I call these the shortcut rules because they allow us to quickly write derivatives from memory without having to always go back to the definition of derivative. So for example, here are some of our shortcut rules. If our function is f of x, on the left we see f prime of x on the right. The derivative of x to the n is n times x to the n minus 1, our familiar power rule. If f of x is sine x, then f prime of x is cosine x. The derivative of tangent x is secant squared x. And the derivative of e to the x is itself e to the x. There are other shortcut rules for the other elementary functions, of course, and depending upon how your textbook is organized, you may or may not have learned all of them at this point in the course. In fact, you may not have even learned all of those given above. We will limit ourselves to these functions in this video, so we will assume you have the above already memorized, or if not, that you can simply look up what you need in this table. So the shortcut rules tell us how to differentiate f of x for certain basic functions f. The chain rule tells us how to differentiate f of something worse, f of some other function of x, or as I refer to it, f of stuff. And what the chain rule says is that the derivative of f of stuff is f prime of stuff multiplied by the derivative of the stuff. That's not very formal language, but I think it helps us find our way through the chain rule. So here's an example. We're going to look at this first one both formally and then informally. So let's look at f of x, at h of x equals x cubed plus 1 to the 4th power. This is a composition of functions, f of g of x. The outside function is f of x equals x to the 4th, whose derivative is 4x cubed. And the inside function, what we are applying x to the 4th to, is the function g of x equals x cubed plus 1, and its derivative, of course, is 3x squared. So the chain rule says h prime of x is f prime of g of x times g prime of x. So we need 4x cubed evaluated at our g of x. So 4 times x cubed plus 1 cubed, and then multiply that by g prime of x, which is 3x squared. And of course we could simplify this if we wanted as 12x squared times x cubed plus 1, the quantity cubed. Now let's look at this same example using somewhat less formal terminology and see how this goes. Again, our function is h of x equals x cubed plus 1 to the 4th. This is basically of the form stuff to the 4th. We have something worse to the 4th. We know the derivative of x to the 4th is 4x cubed. So the derivative of stuff to the 4th will be 4 times stuff cubed, and then we have to multiply by the derivative of the stuff. That's the chain rule part. So our stuff is x cubed plus 1. This becomes 4 times x cubed plus 1 cubed times 3x squared, or again 12x squared, x cubed plus 1, the quantity cubed. If we always talk about it to ourselves the same way, it becomes habitual and we become very proficient at applying the chain rule. So let's look at 3 more examples. Example number 2, our function is h of x equals sine of the quantity 2x cubed. This is of the form sine of stuff. We know from our table that the derivative of sine of x is cosine of x. So for the derivative of sine of stuff, we need cosine of stuff times the derivative of that stuff. Our stuff, in this case, is 2x cubed. So h prime of x becomes cosine of 2x cubed multiplied by the derivative of 2x cubed, which is 6x squared. A third example, let's look at h of x equals the tangent of square root of x. H is of the form tangent of stuff. If we only had tangent of x, its derivative is secant squared x. So to differentiate tan of stuff, we need secant squared of stuff times the derivative of the stuff. Our stuff in this example is square root of x, so h prime of x becomes secant squared of square root of x times the derivative of square root of x, which is 1/2 x to the negative 1/2, or if we want to write this in a somewhat simpler form, we have secant squared square root of x over 2 times the square root of x. Let's do one more example. I don't know about you, but my students always have trouble with the function e to the something. E to the x is easy. The derivative of e to the x is e to the x. But here we have a composition of functions because we have e to the something worse. We have a function of the form e to the stuff. So if it were just e to the x, its derivative would be e to the x. That means our h prime of x, the derivative of e to the stuff, is e to the stuff times the derivative of the stuff. So recalling from our example that our stuff is sine x, this gives us h prime of x is e to the sine x times the derivative of sine x, which is cosine x. And that's the chain rule.